Welcome to the deep dive. Today we are tackling a concept that's, well, it's both the holy grail and maybe the ultimate source of confusion in tech right now. Artificial general intelligence, or AGI.
Yeah, it is frustratingly nebulous, isn't it? For years, the goalposts for what counts as AGI just keep shifting. And AI gets good at something new.
And suddenly that task isn't general anymore.
Exactly, which, it's great for headlines, great for hype, but it's really terrible if you're trying to actually measure engineering progress towards, well, true human-like thinking.
Absolutely. We need a yardstick, not just, a moving target. And that's exactly what we've got in our source material today, a new, really a comprehensive research paper. It lays out a quantifiable framework, basically a scorecard, designed to cut through all that fog.
Right. To finally define AGI using objective, standardized metrics.
So our mission today is to really unpack this whole system.
And the place they start is with a solid, concrete definition. No wiggle room. In this framework, AGI means an AI that can match or exceed the cognitive versatility and proficiency of a well-educated adult.
Okay, versatility feels key there.
It really is. It stresses the breadth of skills across different areas, not just being amazing at one specific thing.
So when the researchers actually used this framework, it spits out an AGI score, 0 to 100%. What did they find? The results were pretty startling, weren't they?
They really were. GPT-4, the model everyone's been talking about, scored, well, a shockingly low 27%.
27%? Wow.
It's a tough metric, no doubt. But, maybe an honest one.
Yeah.
And look, its successor, the paper projects capabilities for what it calls GPT-5, shows huge progress, leaps forward even.
Okay, so what did GPT-5 get?
It still only reached 58%, which is a massive improvement, yes, but it shows there's still a huge gap to close.
Right. So we really need to dig into how they got those numbers, 27% and 58%, because that tells us where the big engineering problems still are for today's AI.
Exactly. What are the weak spots?
So that 27% for GPT-4, what does that actually mean for someone using it? Does that low score mean it's not useful for, say, complex thinking tasks?
Well, it means that while it's brilliant with specific knowledge it was trained on, it starts to falter pretty quickly when you demand real, flexible, general intelligence. It means it's using a lot of clever workarounds. It's definitely smart, but maybe brittle is the right word.
Okay.
To really get the score, you have to understand the foundation. How do you even start quantifying general intelligence in a way that works for both humans and machines?
That seems like the core challenge, and their answer was, look at us.
Pretty much. Since humans are, the only working example of general intelligence we have, the researchers grounded their entire approach in the most rigorously tested model of human cognition out there.
Yeah.
The Cattell-Horn-Carroll theory, or CHC theory.
CHC theory, okay.
Yeah, it's the gold standard in psychometrics for mapping human cognitive abilities. What they realize is you can't just give an AI a general knowledge test from the internet.
Why?
Because a huge language model can use its massive training data, all that statistical knowledge, to kind of fake it. It can pull off what they call a compensatory strategy. It might look like it's reasoning, but really it's just recognizing a pattern it saw millions of times in training.
Okay. So the CHC framework is designed to stop the AI from essentially, well, cheating the test by just regurgitating data.
Yeah.
How does using human cognitive theory prevent that?
By enforcing structure. The CHC theory gives you this detailed hierarchical map of thinking. It breaks down general intelligence into 10 distinct, broad abilities.
Okay.
And those broad abilities cover dozens and dozens of much narrower specific skills like, say, visual processing speed or how fluently you can recall associated memories. The framework tests the AI using the exact same kinds of cognitive tests psychologists use on people.
Got it. So instead of asking it to, I don't know, write a sonnet about cheese, which it can do brilliantly using patterns, they're making it demonstrate specific cognitive functions like manipulating information in working memory or reasoning through a totally novel logic puzzle.
Exactly that. It forces the AI to show both the breadth, that versatility across all the different cognitive domains, and the depth, meaning proficiency, within each one. That 100% score is reserved for hitting that holistic, human-like profile across the board.
All right, let's get into the scorecard itself then. 10 core cognitive components derived from those CHC broad abilities. And crucially, they're weighted equally, right? 10% each.
Yes, equal weighting. That's fundamental because it immediately prioritizes that breadth, that versatility. No single area can carry the whole score.
Makes sense.
And we kind of group these 10 domains neatly. The first 3 are what you might call the pillars of learned knowledge, crystallized intelligence, This is where current AIs, thanks to their massive training data sets, tend to do pretty well.
Okay, walk us through those first three.
First up is general knowledge.
Yeah.
Pretty straightforward. The breadth of factual understanding, common sense, science, history, culture, that sort of thing. Second is reading and writing ability, RW. So not just basic literacy, but sophisticated understanding and production of written language, nuance, grammar, style. And third is mathematical ability, M. This covers the whole spectrum, basic arithmetic, algebra, geometry, all the way up to calculus and probability. And like you said, these models soak up vast amounts of text and data, so they have a head start here.
Okay, that tracks. Those feel like areas where we've seen huge progress. But then we get to the other 7 domains, the foundational cognitive machinery. And this is where the AI mind, the statistical pattern matcher, starts to run into trouble.
That's exactly right. These components measure how the mind actually processes information, especially novel situations, not just what facts it is stored away. So, for instance, you have on-the-spot reasoning.
Okay, what does that cover?
This is about flexible thinking. Controlling your attention to solve problems you haven't seen before. Includes deduction, induction, planning, and this is a big one, theory of mind, understanding what others might be thinking or intending.
Theory of mind. That seems tough for an AI.
Very. Then there's working memory, WM. That's your mental scratch pad, holding information actively in mind and manipulating it, like remembering a phone number while you walk across the room or following complex multi-step instructions.
Right. Got it.
And then we hit the 2 really critical memory domains, long-term memory storage, MS, and long-term memory retrieval, MR. We definitely need to circle back to the scores there because they are, well, they're bad.
Okay, storage and retrieval, noted. What are the last 3?
They cover sensory processing and speed. So visual processing, V. This isn't just image recognition like cat or dog. It's about perceiving, analyzing, reasoning about visual information. Like, can you mentally rotate a 3D shape? Can you predict where a ball will land? Then auditory processing, A. Similar idea, but for sound. Discriminating between sounds, recognizing speech in a noisy room, even working creatively with audio like composing music.
Okay, and the last one is just speed. Speed, S. Why is raw speed part of an AGI definition? If the AI gets the right answer eventually, doesn't that count?
That's a good question. But remember, the definition is matching human cognitive proficiency and versatility. The CHC model includes processing speed because it's a fundamental part of human cognition. The S factor measures doing simple cognitive tasks, quickly, perceptual speed, reaction time. If an AI takes, say, 5 minutes for a thought process a human does in 5 seconds, it's not really operating on a human level in a dynamic, interactive world. It fails the matching proficiency part.
Okay, that makes sense. So we have these 10 domains, equally weighted, and when the researchers put it all together for models like GPT-4 and GPT-5, the picture wasn't the smooth upward curve towards 100%. It was, what did they call it? A jagged cognitive profile.
Jagged is the perfect word. Highly uneven. Those overall scores, the 27% and 58%, they really hide these wild extremes between different abilities.
Right.
But first, we absolutely have to acknowledge the incredible progress. I mean, jumping from 27% to 58% in maybe just a couple of years, that shows exponential growth is happening, especially those data-heavy areas we mentioned.
Can you give a specific example of that jump?
Sure, look at mathematical ability. GPT-4 was notoriously prone to making silly math errors, right? It scored only 4% on this rigorous battery.
Only 4%. Okay.
But GPT-5, presumably with much better training, maybe specialized modules, it hits a proficient 10%. That's the maximum score for that domain. A huge leap.
Wow, okay. From 4 to 10%. And you saw similar gains elsewhere.
Yeah, in those learned knowledge areas.
Yeah.
Reading and writing RW went from 6% in GPT-4 to a full 10% in GPT-5. And even on-the-spot reasoning, that crucial ability to handle novel problems, it went from basically 0% in GPT-4.
0.
Pretty much negligible. Up to 7% in GPT-5. Now, 7 out of 10 might not sound amazing, but going from 0 to 7 in novel reasoning is a massive step functionally. It means it can start to solve problems it wasn't explicitly trained on.
Okay, so definite progress, but there's always a but, isn't there?
There is. And here's where we hit the wall. The real fundamental deficits, the bottlenecks that explain why these systems, despite the progress, are still functionally quite far from AGI. And it really centers on the memory system.
Okay, let's tackle long-term memory storage, MS, first. You hinted the score was bad. How bad?
It's 0% for both GPT-4 and GPT-5.
0. Still 0, even in the more advanced model.
Still 0. According to this framework's testing, these systems demonstrate no independent lasting ability to acquire, consolidate, and store new information or experiences beyond the current interaction. The paper flags this as possibly the single biggest blocker to achieving AGI.
Hold on. If it scores 0 on long-term memory storage, does that mean, practically speaking, that even the best AI today basically gets amnesia every time it closes the chat window or start a new task?
Functionally, yes, pretty much. It's a kind of constant rolling amnesia. Every time you start a new conversation, or if a task needs knowledge built up over days or weeks, the AI has to be re-fed all that context, or it has to try and relearn it from scratch within its current attention window.
Which makes real personalization or learning from experience over time basically impossible.
Exactly. It can't build a persistent model of the world or its interactions.
Okay, wow. 0%. And that failure to store new stuff is then compounded by problems retrieving its existing internal knowledge accurately. That's the other memory domain, long-term memory retrieval, MR. What was the score there?
Only 4%. For both models again.
4%. Why so low? Is it slow at retrieving things?
No, interestingly, it's not about speed. The score breakdown shows they actually get high marks for fluency. They are incredibly fast at accessing and spitting out information related to a prompt. The score is tanked by precision.
Precision. You mean accuracy.
Precisely. They score 0% for precision. Why? Because they hallucinate. They confabulate.
Right. The hallucination problem.
They just make stuff up, mixing plausible-sounding fiction with actual facts from their training data, and they present it all with complete confidence. Since the MR score here demands high-precision, reliable, factual recall, even occasional hallucination on tests designed to measure recall basically destroys the precision score, keeping MR stuck at that low 4%.
So they can access vast knowledge quickly, but they can't reliably tell if it's true or something they just invented.
That's the crux of it.
Okay, so this jagged profile, amazing at math maybe, full marks for reading, but 0 for long-term storage and terrible precision in retrieval. What does this mean for how AI is actually used? The paper talks about capability contortions, right? Workarounds.
Exactly. Capability contortions are the clever engineering tricks used to hide or compensate for these deep underlying cognitive weaknesses.
Yeah.
They create an illusion of generality, but they're often inefficient patches over a fundamental gap.
So let's look at the first contortion. How do systems cope with that shocking 0% in long-term memory storage, MS?
The main workaround is just dramatically increasing the context window. That's the AI's working memory, WM, essentially.
Right.
If the model can't actually store what happened in yesterday's conversation, the workaround is to just feed the entire transcript of yesterday's conversation back into the prompt for today's session.
So you basically load its entire relevant past into its active attention each time.
You got it. This lets the AI seem like it remembers past interactions, because all that data is right there in its working memory for the current task.
But the source argues this isn't a real solution, right? It's inefficient.
Hugely inefficient. And it just doesn't scale. Imagine needing an AI collaborator that needs to build context over, say, a 6-month project. You can't realistically stuff 6 months of meeting notes and documents into the context window every single time you interact with it. It becomes computationally impossible. It's a clever trick, but it's not a mind with real persistent memory.
Okay, makes sense. And the second contortion, how do they deal with the hallucination problem, the low memory retrieval, MR precision?
This is where techniques like ARGOGI come in: retrieval augmented generation.
ARGI. We hear that acronym a lot.
Yeah. Essentially, you're hooking the language model up to an external reliable knowledge source, like a database or a set of verified documents, maybe even live web search.
So it's like fact-checking the AI before it speaks.
Kind of. Before the AI generates an answer, the array system retrieves relevant factual snippets from that trusted external source. Then it forces the AI to base its answer on those retrieved facts, rather than just relying on its own potentially faulty internal knowledge.
So you're basically duct taping a reliable external brain onto the creative but hallucinating internal one.
That's a good way to put it. It makes the AI much safer and more factually reliable for the end user, which is great, but it completely masks the underlying cognitive deficit. The AI itself hasn't stopped hallucinating internally. We've just built guardrails around it to prevent those hallucinations from getting out. It hasn't learned to be precise, it's just being fed precision.
It obscures the fact that it lacks a truly dynamic, reliable internal memory system capable of learning and self-correction.
Precisely.
Which brings us to this really powerful analogy the researchers use to tie it all together. The artificial mind is like a high-performance engine, but its overall power is limited by its weakest parts.
Yeah, I love this metaphor. It perfectly explains why that 58% overall score for GPT-5, while impressive on the surface, is still deeply problematic from an AGI perspective. You could have an engine, an AI, that scores 90% or even 100% in 9 out of 10 areas.
Yeah.
Amazing math, perfect language, incredible reasoning.
Right.
But if it scores 0% on long-term memory storage, MS, that single failure acts like a seized piston. The entire engine is fundamentally crippled. It's functionally impaired by this persistent amnesia. That one catastrophic weakness limits the overall usable intelligence of the system, no matter how brilliant its other components are in isolation.
That's a really crucial point. The system is only as strong as its weakest link, cognitively speaking. And we absolutely need to remind listeners this framework is laser focused on human level cognitive abilities. We're talking human level AGI here.
Right.
This isn't about whether an AI is economically valuable or useful for specific tasks. Clearly, even a model scoring 58% on this strict cognitive scale is already transforming industries, but that usefulness doesn't make it cognitively versatile like a human adult.
Exactly. The big takeaway here isn't just the scores themselves, but the power of the framework as a diagnostic tool. It forces the field to move beyond just chasing benchmark scores on specific tasks, and instead to stare unflinchingly at the deep foundational weaknesses.
It pinpoints where the real breakthroughs are needed.
Yes, it shines a spotlight on the grand challenges, like achieving true, continual learning, fixing that 0% in MS, and solving the hallucination problem at its root, fixing the precision issue in MIS-R. That's where the fundamental research needs to go.
Which leads to a really interesting, maybe even a slightly mind-bending final thought to leave people with. The paper points out that complex thinking in humans almost never uses just one cognitive ability in isolation, right? They're deeply interdependent.
That's right. Like solving a hard math proof isn't just about mathematical ability,
Yeah.
M. It also requires strong on-the-spot reasoning, good working memory, WM, to track the steps, maybe even drawing on general knowledge, K.
So, if that engine analogy holds true, if the whole system is constrained by its weakest parts, those 0% bottlenecks we talked about, what might happen to the AI's overall capability profile if researchers manage to fix just one of those fundamental flaws? Say they finally crack long-term memory storage.
Well, the implication in the research is that fixing even one major bottleneck could have nonlinear, maybe even explosive effects on the entire system's performance. Suddenly, that high-scoring reasoning ability or that perfect math skill is no longer held back by the amnesia problem.
They can be fully utilized together.
Exactly. The components could start working together synergistically in ways they simply can't right now. Fixing that one broken part might suddenly unlock the potential of all the other high-scoring parts, potentially driving that overall AGI score way beyond 58%, much faster than we might expect. Wouldn't just be incremental progress, it could be a phase shift in capability.
A fascinating and perhaps slightly unnerving thought to ponder as we watch this field continue to evolve at breakneck speed. Thank you for taking this deep dive with us today.